Hi guys. Okay, so in this video, we are looking at the homework questions 55, 57, 61, and 63. These are the questions that relate to the chapter 11, acids and bases. And we are looking at the first problem, 55, which is the complete and balancing the equation. So here it's always outer, outer, inner, inner. It's very important that you identify the metals, polyatomic ions, or the non-metals. Okay, so here we see that the metals is the zinc, and then hydrogen is, they are the cations. And then we have the carbonate, which is a polyatomic ion, and then we have the bromide. Now, here is very important that, let me just put this here, this and this will connect, and these two will connect. Okay, so here we see, in this case, very important, you should know what are the symbols. So signs, so zinc is +2 and carbonate is -2. So that's why the +2 and -2 cancel out. Hydrogen is +1, and bromide is -1. So when they crisscross, so when they're going to crisscross, this is going to give you ZnBr2, ZnBr2, and the other one is going to give you H2CO3. Remember that zinc, let me put this here, zinc with its +2 charge and bromine -1 charge. And here you have hydrogen +1 charge and carbonate is -2 charge. So here when they crisscross, so this number comes here and this number goes there. But for 1, we don't write. This number is here. For 1, we don't write, but the 2. That's how you get H2CO3. But H2CO3 is unstable. So this is an unstable acid. So what is going to happen now? This unstable acid is going to break up into H2O and CO2. Okay, so now we see balancing. So we see that there are 2 bromines on this side, 2 bromines here. There is 1 zinc here, and then we have 2 hydrogens, and we have 1 oxygen, we have 1 carbon, and we have 2 oxygens here. But on the other side, we have 1 zinc, we have 1 carbon, we have 3 oxygens, and then we have 1 hydrogen, and then we have 1 bromine. So what is not balanced? Bromine is not balanced. So what are we going to do? We're going to put 2 in front of here. So when you do this, now we have 2 hydrogens, that makes 2 hydrogens and 2 bromines. Okay, so because that's so now 2 bromines balance, 2 hydrogens balance. So let's go back and check. 2 hydrogens, 2 hydrogens, 2 bromines, 2 bromines. Okay, a total of 3 oxygens and 3 oxygens, 1 carbon, 1 carbon, 1 zinc, and 1 zinc. Okay, so these are the, this is how you balance it. So make sure that whenever the acid is unstable, you break it up into these 2. Okay, so this is one piece. Next is HCl with sodium bicarbonate. So same thing is going to form. This is keep this in mind that this is the bicarbonate anion, and this is sodium. This is hydrogen, and this is chlorine. So what is going to happen now? That chlorine and sodium interact, and hydrogen and bicarbonate interact. So what are you going to get here? We will have NaCl, and we will have NaCl and H2CO3. And same story with H2CO3. Always, this is going to break up into, or we can simply write down the, this way, HCl plus NaHCO3, and that is giving you NaCl plus H2O plus CO2. Now, another way you can also, it's very important, this is aqueous. This is also aqueous, soluble in water, sodium salt, right? Sodium chloride is also soluble in water, aqueous. Water is liquid, and carbon dioxide is gas. And if you look at, it's all like balanced. So this is 1 hydrogen, and 1 hydrogen make 2 hydrogens. 1 chlorine, 1 sodium, 3 oxygens here together, and 1 carbon, all balanced. Okay. Next is balance the neutralization reaction. Simple, again, balancing. So you see, let's do this here. So we have 1 hydrogen, we have 1 chlorine, we have 1 magnesium, we have 2 OH, let's break this up, 2 oxygens and 2 hydrogens. And we have here 2 hydrogens, 1 oxygen, 1 magnesium, and 2 chlorines. So what is not balanced? We look at the balancing. Obviously, chlorines is 2 here and 1 here. So let's start with that. We can put 2. Let me put this in. We put 2 here. So 2 times, that changes the hydrogens also. So now there are 2 hydrogens and 2 chlorines. So chlorine and chlorine is balanced. Hydrogen and hydrogen is also balanced. Next is the, let's count others. Now we have 1 magnesium, 2 oxygens, and there is only 1 oxygen here, 2 hydrogens, and we have, so we have to change this, go back and change this. So 2 oxygen. So if we make this 2, wait a minute here. So this becomes 4 hydrogens, and we have 2 oxygens. So 4 hydrogens. So we will have to change this. So 2 and 2 and 2. So that makes 2 magnesiums, 4 oxygens, and 4 hydrogens. 4 hydrogens. Man, what is happening? Wait a minute. No, wait. Maybe not. No. Oh, sorry, I forgot about the other hydrogen. So don't change that. Keep it like this. Sorry about that. No. Late night. Anyways, just bear with me here. Okay, so we have 1 magnesium and 2 oxygens, 2, yeah. So here's your, so 2 and 2, 4 hydrogens. Okay, like that, and 2 chlorines. Okay. Okay, so that balances everything. And so that's a neutralization reactions. Okay, next is we're going to look at these calculations that relate to titrations. The whole process of titration I have already explained in the lecture. So we're just going to look at this. So we are given, let's write down this here. What is given? HCl are given 5.00 milliliters. Okay. What is the molarity of the solution of HCl? So we need to find the molarity. Volume given is 5.0. Find the molarity. What about the NaOH? We are given the volume of NaOH is 28.6 milliliters. Okay. And then the molarity given is 0.145 m. Okay. So what are the steps here? Anytime you're given these titrations, so first of all, always write these steps, like understand that milliliters have to be converted to liters. Next is find the moles of the base. If you know the molarity and the volume, find the moles using molarity times the volume. Next is using the mole to mole ratio, find the moles of the acid, okay, based on the balanced equation also. So this is a balanced equation. Moles of the acid, how do you find this? You take the moles of the base, okay, times the mole to mole ratio of the acid, moles of the acid over the moles of the base, okay. So that's going to give you the moles of the acid. What's the fourth thing you'll do? You're going to take the moles of the acid, divide that by the volume of the acid in liters, and that's going to give you the molarity of the acid. Okay, so let's do this. Here, first is 5.00 milliliters times 1 liter over 1000 milliliter. So that gives you 0.005 liters. Next is 28.6 milliliters times 1 liter over 1000 milliliter, and that gives you 0.0286 liters. So that's one piece. That was the first step. Next is moles of the base. So moles of NaOH. So what are those moles of NaOH? How do you find them? You take the molarity of NaOH and times the volume of NaOH. So here the molarity is 0.145 m times the volume, which is 0.028 liters. Okay, so let's do this. What do you get here? You have 0.145 times 0.028. Okay, and you get 0.00406 moles. Okay, so these are the moles of NaOH. Next, you're going to find the moles of HCl. So the moles of HCl is equal to, you take the moles, so this is, let's put it here, NaOH, N. So moles of NaOH times the moles of HCl over the moles of NaOH from the balanced equation. So here you have 0.00406 moles. That's the moles of NaOH times the moles of HCl. 1 mole of HCl is reacting with 1 mole of NaOH. So it's the same, right? But so I have to do this so that in case there are like 2 moles or 3 moles reacting, so you have to like pay attention to that, okay? So here we got the same moles, same. So moles of HCl. So next is the fourth step. You take, so this is 0.00406 moles of HCl. Next is you take the molarity is equal to moles over the volume in liters. So here 0.00406 moles of HCl over the volume in liters. So volume was 0.005 liters. Okay, so let's do this. Divide by 0.005 is equal to, so this comes out to 0.812 m. That is the molarity for HCl in this reaction. Okay, so that's the process you will follow. All right, let's look at the next problem here, where we have a different, acid. So here we are given the same thing we will write. So we are given 38.2 milliliters of 38. So volume is 38.2 milliliters. And the molarity given for the KOH is 0.163 m. Okay. Is required to titrate 25 milliliters of HCl. Volume is 25.0 milliliters. What is the molarity of H2SO4? Find the molarity. So same process. So let's do this here. So first step is that 25.0 milliliters times 1 liter over 1000 milliliters. And that gives you 0.025 liters. Second is 38.2 milliliters times 1 liter over 1000 milliliter is equal to 0.0382 liters. Okay, so that's one piece. Next is the moles of KOH is equal to the molarity of KOH times the volume of KOH. So here the molarity is 0.163 m time. The volume is 0.005 0.0382 liters. Okay, let's do this. 0.0382 times 0.163, and you get the moles is 0. So this is the moles of KOH, and that is 0.00622 moles. Okay, next is you take the and then find H2SO4, moles of H2SO4. So how do you do that? You take the moles of KOH, sorry. And so moles of KOH is 0.00622 moles times the mole to mole ratio. And here you have from this 1:2 ratio, H2SO4 1 mole reacting with 2 moles of KOH. So 1 mole of H2SO4 reacting with 2 moles of KOH. Okay, so here we have now times 2, and that gives you the 0.0124 moles. So these are the moles of H2SO4. Okay, so this is the value of the H2SO4. Next is the molarity. Molarity is the moles of H2SO4. Divide that by the volume of H2SO4 in liter. That is in liters. So 0.0124 moles of H2SO4. Okay, divide that by the volume is 0.025 liters. So here 0.0124, divide that by 0.025, and that gives you 0.498 moles. So the molarity of H2SO4 approximately is 0.50 m. Okay, so this finishes your homework from this chapter 11, and thank you for watching.